Hello guys, welcome to Apex Math. My name is Bino. In this video, we go through question 2 from the April 2025 N5 Math question paper. Question 2.1, we differentiate the following using first principle. And we have our formula for first principle, but we are going to first focus on our numerator. We already have the f of x given as equals to 4x minus 3 divided by x plus 2. Now we are to determine the f of x plus h, and we can realize that where there was x, there is now x plus h. So even inside the function where there is x, we substitute x plus h minus 3. In the place of the x in the denominator, we substitute the x plus h plus the 2. Our f of x plus h we simplify and it will be equals to, so we distribute the 4, and 4 multiplied by x is 4x, and 4 multiplied by h is equals to 4h. We have the minus 3, and in the denominator we have the x plus h plus 2. So now we have f of x plus h. In the numerator of the formula for first principle, f of x plus h minus f of x is equals to, the f of x plus h is equals to 4x plus 4h minus 3 divided by x plus h plus 2 minus f of x, and our f of x is equals to 4x minus 3 divided by x plus 2. And we simplify, and this will be equals to, so our LCD is equals to x plus h plus 2 multiplied by x plus 2. In the numerator, we have 4x plus 4h minus 3 multiplied by x plus 2 minus the 4x minus 3 multiplied by x plus h plus 2. We first start by distributing that x into the other parentheses, and x multiplied by 4x is 4x squared, and x multiplied by 4h is 4xh, and x multiplied by negative 3 is negative 3x. Now we distribute the 2, and 2 multiplied by 4x will be equals to 8x, and 2 multiplied by 4h will be equals to positive 8h, and 2 multiplied by negative 3 is equals to negative 6, minus into, we distribute the 4x, and 4x multiplied by x will be equals to 4x squared. 4x multiplied by h will be equals to 4xh, and 4x multiplied by 2 will be equals to positive 8x. And now we distribute the negative 3. Negative 3 multiplied by x will be equals to negative 3x. Negative 3 multiplied by h will be equals to negative 3h. and negative 3 multiplied by 2 will be negative 6. And we are dividing through by x plus h plus 2 multiplied by x plus 2. So let's simplify. We have 4x squared plus 4xh then negative 3x plus 8x will be equals to positive 5x plus 8h minus 6. Let's distribute the negative inside the parentheses and also add the 8x minus 3x. So we have negative 4x squared minus 4xh. We have 8x minus 3x, which will be positive 5x. The negative will make it minus 5x, and the negative multiplied by negative 3h will be positive 3h. Negative multiplied by negative 6 will be positive 6. And we are dividing through by the x plus h plus 2 multiplied by x plus 2. And from here, we are going to cancel a few terms. That 4x squared will cancel out with that minus 4x squared, and the positive 4xh will cancel out with that negative 4xh. The positive 5x will minus with that negative 5x, and the negative and the positive 6 will cancel out, such that we'll be left with 8h plus that 3h, which will be equals to 11h divided by x plus h plus 2 multiplied by the x plus 2. Remember, this was equals to f of x plus h minus f of x. We already now determined the numerator of the first principle. So from here, let's substitute. We have the limit of f of x plus h minus f of x. We determined it to be equals to 11h divided by x plus h plus 2 multiplied by x plus 2, as our h approaches 0, but we have to divide by that h. We use the old division sign, so we divide by h. We change the division sign and we make it a multiplication sign. Remember, the h is divided by 1, and when we change the division to multiplication, this will reciprocate and we'll have 1 divided by h. The h and that h will cancel out, and we have the limit of 11 divided by x plus h plus 2 multiplied by x plus 2 as h approaches 0. We can now substitute, and our f prime of x using first principle will be, we drop the limit when we substitute the h. Where there is h, we substitute 0. So we have x plus 0 plus 2 multiplied by x plus 2. The f prime of x, the derivative using first principle, is equals to 11 divided by x plus 2 multiplied by x plus 2, which will be equals to 11 divided x plus 2 multiplied by x plus 2 will be x plus 2 raised to the power 2. And this will be the derivative of our function using first principle. Moving to the next question. Question 2.2.1, we are going to differentiate the following function. To differentiate the following function, the first term we are going to use a logarithmic law, which states that if we have the ln of a divided by b, this is equals to the ln of a minus the ln of b. We have the 2x plus 1 as our a and the 2x minus 1 as our b. Our y will be equals to the ln of 2x plus 1 minus the ln of 2x minus 1 plus 2 multiplied by the arctan of 2x. And from here we differentiate the y with respect to x. And the derivative of the ln of 2x plus 1, we have 1 divided by the function which is inside the ln, the 2x plus 1. So we divide by the 2x plus 1 multiplied by the derivative of the same function inside the ln. The derivative of the 2x is equals to 2 and the derivative of the 1 is equals to 0. Minus the derivative of the ln of 2x minus 1, which is equals to 1 divided by the function which is inside the ln, the 2x minus 1 multiplied by the derivative of the function which is inside the ln. The derivative of the 2x is equals to 2 and the derivative of the negative 1 is equals to 0. Plus 2 multiplied by the derivative of the arctan of 2x, which I demonstrate at the top right. If we have the arctan of f of x, its derivative will be equals to, in the denominator we are going to have 1 plus the f of x squared. In the numerator we have the derivative of the f of x. In the same way, the 2x will be our f of x. In the denominator we are going to have 1 plus the 2x squared, and in the numerator we have that the derivative of that 2x, which is equals to 2. We simplify, and the derivative of the y with respect to x will be equals to 1 multiplied by 2 is equals to 2 divided by the 2x plus 1 minus the 1 multiplied by 2, which is 2 divided by 2x minus 1 plus that 2 multiplied by 2 will be 4 divided by 1 plus 2 squared, which is equals to 4 multiplied by x squared, which is x squared. And this will be our derivative. Question 2.2.2, in order for us to differentiate the following function, we are going to use the chain rule, because we only have 1x, which is raised to the power 3, but we have sine, we have tan, and we have cos. We also have to consider the fact that our function is raised to the power 5. So the derivative of y with respect to x, this will be equals to that 5 from this inner function. We multiply the 5 by the sine of the tan of the cos of x raised to the power 3. And remember that we minus 1 from the exponent, and 5 minus 1, 5 minus 1 is equals to 4. Now we differentiate the inner function. We start by differentiating the sine, and we leave the inner function of the sine. The derivative of sine is equals to cos of the inner function as it is, the tan of the cos of x raised to the power 3. Now we differentiate the inner function of the sine, the tan, and we leave the inner function of the tan, and the derivative of tan is sec squared, and we write the inner function of the tan as it is, the cos of x raised to the power 3. Now we differentiate the inner function of the tan. We differentiate the cos and we leave the inner function, the x cube, and the derivative of cos is negative sine of x raised to the power 3. And finally, we differentiate the inner function, the x cube. The derivative of the x cube will be equal to 3x squared. But we can move that negative to the front, and that 3 multiplied by that 5 is equal to 15. We now have our negative 15, and this will be our answer for question 2.2.2. Moving on to question 2.3, we have to differentiate the following function using logarithmic laws. And the logarithmic law that we are going to use states that if we have the ln or the log of a raised to the power b, this is equals to b multiplied by the ln of a. So we are going to introduce a ln or log both sides of the equation, and on the left we have the ln of y, and on the right we have the ln of the 2x plus 1 raised to the power sine of 4 pi of x. Remember that we introduced the ln both sides of the equation so that we can get rid of the sine 4 pi x as part of the exponent. We had the ln of a raised to the power b, that b became part of the base. So even that sine 4 pi x will become part of the base. So we have the ln of y is equals to the sine 4 pi x is removed as part of the exponent, and we multiply it with the ln of 2x plus 1. Perhaps let's put parentheses around the 4 pi x. Now we differentiate. The derivative of ln y will be equals to 1 divided by the function inside the ln, which is y. And when we differentiate a function involving y, we multiply by dy over dx. On the right hand side, we have a product of two functions, the sine of 4 pi x and the ln of 2x plus 1. So we use the product rule to differentiate. To use the product rule, we are going to write the first function and we differentiate the other. So we are going to have the sine of 4 pi x, and we differentiate the ln function, and the derivative of the ln function will be 1 divided by the function which is inside the ln, the 2x plus 1 multiplied by the function which is inside the ln, the 2x plus 1. The derivative of the 2x is 2, and the derivative of the 1 is 0, plus we are going to have the ln of 2x as it is, the ln of 2x plus 1. We just write it as it is, and we differentiate the sine function, and the derivative of the sine is equals to the cos. We leave the inner function as it is, the 4 pi x, and then we multiply this by the derivative of the inner function. The derivative of 4 pi x is equals to 4 pi. And we can now simplify. We have 1 over y multiplied by the dy over dx equals to, we write that 2 first. So we have the sine 4 pi x multiplied by 1 multiplied by 2. We write the 2 multiplied by the sine of 4 pi x. And this is divided by the 2x plus 1 plus, let's write that 4 pi first. So we have the 4 pi multiplied by the ln of 2x plus 1 multiplied by the cos of 4 pi x. We have to have dy over dx on the left hand side, so we remove the 1 over y by multiplying both sides of the equation by y. We multiply both sides of the equation by y, and that y on the left hand side and that y will cancel out, and our dy over dx will be equals to the 2 multiplied by the sine of 4 pi x divided by 2x plus 1 plus 4 pi multiplied by the ln of 2x plus 1 multiplied by the cos of 4 pi x multiplied by that y. But we cannot have the y in terms of y, we have to have it in terms of x. So we have the 2x plus 1 raised to the power sine 4 pi x as our y. So in the place of the y, we substitute 2x plus 1 raised to the power sine 4 pi x. And this will be our derivative using logarithmic laws. Question 2.4, we differentiate the following function involving inverse trigonometric functions. We use our formula sheet, and in order for us to differentiate the arc cosec x, we are going to use that last one, and the derivative is just straightforward. We have -1 divided by the x multiplied by x squared minus 1. For the arc cot x plus y is not going to be straightforward like when we have the arc cot x. Suppose that we have the arc cot of f of x. The derivative will be the derivative of this with respect to x. In the denominator, we are going to have 1 plus the f of x raised to the power 2, and in the numerator we have the derivative of the f of x. We have actually the negative derivative of the f of x. For our question, we are going to have 1 plus, remember that we had f of x which we squared, and in the numerator we differentiated it. So our f of x in this case will be the x plus y. So we have the x plus y squared, and actually the derivative of the arc chord has a negative, so we are going to place that negative there. So the derivative of that x will be 1, and the derivative of the y will also be 1, but we multiply it by dy over dx because we differentiated a function involving y. And on the right hand side, the pi is not attached to any x, so it's a constant. Its derivative is 0. Let's simplify. We move that to the right. It has a negative sign. It will change sign to positive. Now on the left, we have negative 1 plus dy divided by dx divided by 1 plus x plus y raised to the power 2, and this will be equals to, so that negative will change sign to positive 1 divided by x multiplied by the square root of x squared minus 1. Let's multiply both. So we have to make the dy over dx the subject of the formula. So we multiply both sides of the equation. So by negative, to remove that negative, negative 1 plus x plus y raised to the power 2. What we do on the left, we do on the right. We have minus multiplied by 1 plus x plus y raised to the power 2. On the left hand side, the negative and the negative will cancel out, and that will also cancel out with what we have in the denominator, and we'll be left with 1 plus dy over dx is equals to, on the right hand side, we are going to distribute the negative sign. So we are going to have negative 1 minus the x plus y raised to the power 2 divided by x multiplied by the square root of x squared minus 1. We are going to remove the 1 from the left to the right, and our dy over dx will be equals to that minus 1. In the memorandum, next to the x plus y squared, there they have a positive. It's not supposed to be a positive, it's supposed to be a negative, because we distributed the negative and it affected the 1 and the x plus y squared. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.